Hi, my name is Dave Long, and I'd like to show you how to use Aircrack to crack WPA and WPA2 Pre-Shared Keys. There will be a number of links that I use in this video, and I'll include them at the end of this. Now, the first order of business is going to be find a wireless adapter that will work well with Linux. Aircrack has a portion of their website that's devoted to compatible wireless adapters, and there's a link that will be included with this video to this page. About 3/4 of the way down, there's a list of compatible adapters. And if you're looking for a cheap option, I went with the USB adapter. It was the Netgear WG111 version 2. So the second order of business will be visiting the BackTrack website, start downloading the ISO. To each their own, but I prefer the GNOME for a window manager. And I will catch up after this download finishes. Our second task will be downloading VirtualBox so we can start a VM of BackTrack. We'll be using BackTrack 5 Release 3 throughout this video. You can use any virtualization software you'd like, but VirtualBox is of course open source and free. We'll include a link to the download page. I've actually already done that previously, so I'll just open VirtualBox. So you want to create a new virtual machine, name it what you will. Two gigs of memory is sufficient. And we'll go ahead and create that, basically using all the defaults. When asked for installation media, just browse to the location where you downloaded the ISO of BackTrack 5 Release 3. At this screen, when you see boot, hit enter, and just accept the default. And when you finally get to a prompt, type in startx to open a GUI. Now, if you haven't already connected your USB adapter, or whatever adapter you're going to pass through, do so now. And for a USB device, you right-click on this little USB icon and select your adapter, and we'll pass it through to the virtual machine. And at times you may have to disconnect and reconnect the USB device. I actually just had to do that. And the first command we're going to use is airmon-ng, and this is basically just, it will give you a status and show you any connected wireless adapters that have functioning drivers. So here you can see the adapter that we have is going to be referred to as WLAN 0. So you're going to want to use airmon and start it on your adapter. This next command, arrow dump, will display everything that this wireless adapter is receiving that is in promiscuous mode, as in it's just receiving any frames that it can. And if we use arrow dump and type in the name of the adapter that we just created, mon0, which is a monitor adapter, it's a virtual adapter that just will pass all the traffic that WLAN 0 is receiving. If we use this command, this is where we'll start. This command will just cycle through all of the wireless channels and show you the BSIDs, it's the MAC address of the access point, and any associated clients down below. And right now we don't see anything yet, but as soon as we see a station with an associated BSID, we can move on to the next step. The idea is going to be, we want to disconnect the client and capture the four-way handshake that takes place when a client successfully authenticates to an access point that's using WPA or WPA2 Pre-Shared Key. Now this scan has been running for some time, and I've noticed, and for the record, this is the test SSID we're going to be using. This is my access point, Fort Rad. I can see that there is a station associated with it, so this looks like a decent target. So what we're going to do is stop this arrow dump that's running, and we want it to specifically show us traffic from channel 6. Up here you can see that Fort Rad is using wireless channel 6, and we want it to only dump traffic from the BSID that belongs to Fort Rad. And the last switch that we're going to use, because we want to start capturing these packets because we've acquired a target, this is /w. This is the prefix of the file name that you're going to be writing all of these captured packets to. I'm just going to keep it simple and name it Fort Rad, and then we'll just tack on a number after Fort Rad, and it'll just be a series of .cap files that you can manipulate later. And if you happen to capture a four-way handshake, we'll see some text written up here. Obviously we don't see it just yet, but that is our goal, to either disconnect the client and catch their four-way handshake because we forced it, or to just organically see a four-way handshake. There are times when nodes will have to reconnect to the access point, and we can also catch a four-way handshake that way. But if we don't feel like waiting, we can use a tool called Airreplay to disconnect this client by sending deauthentication frames to both the access point and the client. So the way we're going to use Airreplay, the command begins with Airreplay. The first switch is going to be which kind of attack, and -0 is a deauth attack, which is the easiest way to force a client to initiate the four-way handshake again with the access point. The next number is going to be how many of these attacks you want to run. For each iteration of this command, it will send 64 deauthentication frames. We usually start with about 5. You can do a maximum of 65. You want to specify the access point, so we're going to put the MAC address of the access point in here, and specify which client. This is actually a mobile phone I have in this room that is connected. And you want to specify the interface of the frames that you want to replay. So we're going to let that run a few times, and you want to see acknowledgments back from the client. So this first number that is coming back with a bunch of zeros means that the client isn't acknowledging this. So we can try and send a few more deauthentication frames. And we see a few acknowledgments, and actually up here you can see we've already caught a WPA handshake. So we can cancel it. We can stop this script from running just because it's no longer necessary once you see a WPA handshake has been captured up here. So at this point we can cancel AeroDump because we have what we need. We have a four-way handshake, and we can start to crack this and try to basically what any program will be doing is running through a list of words, or either coming up with the words on the fly, running them through the same algorithm that WPA and WPA2 uses, and trying to come up with a hash. If it matches the hash that it sees in this capture file, then you know you have the right password. So if you browse to your home folder, by default this is where we've been working. It's the working directory, I mean to say. And so this fortrad01 or -01.cap is the capture file that has a WPA handshake that we would like to crack. And one more thing before we move on to actually cracking this password. I'm sure some of you are wondering, if you had been running this capture for hours, you may have a very large capture file. How can we clean that up to get rid of all the traffic that we don't need and just hang on to those 4 frames that have the WPA handshake, basically what we're looking for. So there's a utility called WPA clean. Now, we hadn't been running this packet capture for very long, so the results of this WPA clean won't be very pronounced, but they will still be noticeable. So here we have the original capture file. It's 270 kilobytes. This, if it had been running for an hour, it could be a couple hundred megabytes. Now, I just wanted to leave this output up here just because I don't know, in my mind it doesn't quite make sense to me. But the order that you type the command in is WPA clean, the new file that you would like to come out of this command, followed by the input file. So I want the new file to be called fortrad01 slim. This is something I used to indicate it's been cleaned up. And the input file will be fortrad01.cap. So now you can see we have this new fortrad01 slim.cap file that's very tiny, 650 bytes, not even a kilobyte. So this file we can start cracking. We could have just started cracking the first file that we had. Again, this is just an example for what you would do if you had a very large capture file. Now, before we can start cracking, we need to download a word list file or a dictionary file. This will be the starting point. This will be the source of words that Aircrack will cycle through and run through the same algorithms that WPA and WPA2 uses to come up with hashes. Now, searching for word lists can land you in some nefarious places, so I will leave that up to you. But everything is really just a Google search away. There are a number of ways to transfer this to your VM. To make it easy on myself, I just slapped it on a USB stick. So I'm going to pass through the USB device like I did the wireless device. Sometimes you may have to eject it from your host. And I will copy this over to the root directory. Now you could keep this wherever you wanted, but it just makes it easier if it's in the same directory that your capture file's in. Then you don't have to change directories or type in the entire path. And once you have that word list file in your root directory, you can use the Aircrack command, which is why we're all here today. The first switch is a -w, where you specify the word list you'd like to use. That's going to be rocku.txt, which is a decent introductory word list if you find it. And then you have to specify the capture file you'd like to start cracking. So that, like we said, is going to be Fort Router 1 Slim. So Aircrack will run through all of the words in this word list and either come back with an answer, come back with a cracked key, or it will say that it has exhausted the entire word list and it can't be found in that dictionary. And so I will skip ahead until either one of those things happens. So here we are, just under 4 minutes later. We've cracked this WPA2 network's pre-shared key, and it is the word paper towel. Obviously this isn't the greatest word to choose because it's based on 2 English words, and point in case, it could be cracked in a matter of minutes. The thing is, we kind of got lucky that we were able to find this easy to find string within the first 168,000 keys or so. And this took 4 minutes, which seems like no big deal, but if you wanted to search through millions, that could take days. So what we want to be doing, instead of using the CPU like Aircrack uses, what would be nice would be if we could use our GPU or GPUs to run through many more cycles than a CPU is capable of. So we're going to use a program called Hashcat, which is a Windows application that works to use your GPUs to create hashes in the same way your CPU would, but at a much faster rate. So before we shut down our Linux VM and we move into the Windows world again, we just want to copy that capture file to external storage so that we can move it over. So I'm going to put it onto my USB drive like I did before. You'll find a link attached to the hashcat-gui website where you can download hashcat-gui, which is just a GUI interface for what is normally a command line driven application. And while you're at it, you'll want to visit the converter section of the website, because this is where you will upload a capture file that will be converted into a .hccap file. This is just a proprietary capture file that Hashcat uses. So you'll just want to find where that output file is displayed. You don't have to rename it, I'm just doing this for my own sake. And after you install Hashcat, you'll be asked which type of GPU you have. In my case, I have 2 AMD cards, AMD HD 6950s. And you'll want to switch to the Hashcat Plus tab. Hashcat Plus specifically is designed to use your GPUs. versus the CPU to create hashes. You'll want to change the hash type to WPA/WPA2, and up top under the hash file you'll want to browse to the location where you saved your hash. In this case I put my and after that you'll just want to add the same word list that you were using before. One last important step is to check this box down here where you will write the recovered hash to file. This will display the SSID and the cracked pre-shared key if and when it's found. One last thing to note before you get started: this GPU watchdog number is the degrees Celsius that your computer will shut off. This is to protect your graphics card from overheating. You may want to look into software like SpeedFan. Again, I'll include a link. This is very simple software that will monitor the internal temperatures of certain hardware, namely the CPU, GPU, motherboard. It's just a good tool to monitor speeds of fans and just overall temperatures, just to make sure that nothing bad happens while you're trying to crack a password. One last thing, unfortunately I'm not sure what's going on with the hashcat project these days, just because I haven't seen an update on the website in a while. But their software unfortunately doesn't run these days. If you try to start this crack, you'll get this error that says that hashcat plus is outdated. Unfortunately on their website there isn't a more recent version available, so the only workaround that I'm aware of at this point is to change your system time. If you set the date back to anywhere in 2011 or earlier, it seems not to have an issue. So the interface is pretty crude, but it obviously is designed not to rob too many CPU cycles, and as you can see, this is what I meant to demonstrate. This hash has already been cracked. It took a total of 4 seconds to run through the same amount of words, about 170,000, and this took the CPU about 4 minutes to crack. So if you do the math, it's about 60 times faster to use the dual GPUs that I have in my setup. I'm using what I believe a typical gamer would probably invest on, something like this or better, 2 Radeon HD 6950s, and like I said, on average using dual GPUs in this situation is about 60 times faster than a CPU would be, but your mileage may vary. It all depends on the hardware that you have. But as you can see, it's not a very complicated process to capture a WPA or WPA2 handshake and run it through the cracking process. So obviously the only good defense against pre-shared key cracking is a long, complicated password.